Hello and welcome back to another episode of Math with Sohn. Today we are going to be dealing with the infamous Pully problem, where you can think of this as with a 3 kilogram on one side and a 5 kilogram on the other side, one of them is going to win. And I'll give you a hint, the 5 kilogram, it weighs more, therefore it is going to win, and you need to think of this as kind of like a unit, okay? So with that being said, the 3 kilogram is going to go up, while the 5 kilogram goes down because 5 kilograms will weigh more and naturally it will win in terms of like strength and force. But because they're one unit, they are going to be accelerating the exact same speed. Well, one's going up, one's going down. If you take out negatives in the mix, you'll be able to deal with that, okay? And remember that force is equal to mass times acceleration. Therefore, the sum... Oof, that was the worst sigma. The sum of all of your forces will equal your mass of the total system times the acceleration of the system. And if we wanted to solve for the acceleration of the system, we could get the sum of all forces divided by the mass of the total will equal the acceleration of the system, which could be very useful, okay? Because we can find the acceleration of the system, therefore we could separate it out to find what is the tension of each individual rope and so on and so forth. So with that in mind, how is this accelerating? What is the real mass of the system? Well, the mass of the system is going to be 8 because you would have to combine these. It's not like the 3 kilograms is going to make the 5 kilograms weigh any more. This entire rope system is moving. Therefore, you will have to combine those together to get 8. For the bottom, 8 kilograms. But the overall net force is going to be different, okay? Because gravity is affecting them both, but the forces that are happening, the 5 kilogram is being pulled downward, and it is being counteracted by the 3 kilogram, which is kind of also being pulled downward. It ends up losing, therefore, the combination of the two will actually be the 5 kilogram times gravity, but then you have to take away, I'm out of room, take away the 3 kilogram times gravity because that 3 kilogram is kind of counteracting it. So the force there will be 5 times 9.8 minus the 3 times 9.8 because it is opposing the 5 kilogram one. If we do the math for that, 5 times 9.8 minus 3 times 9.8, and we divide by 8, we get the acceleration of the system is equal to 2.45 meters per second squared in the downward direction, negative 2.45 meters per second squared, because it will go down on the right side. But it will also be going up at 2.45 meters per second squared on the left side, on the 3 kilogram side. Okay, well that's part one. The acceleration of the system. Part two is what is the tension on the cord? For the tension on the cord, you need to think of this separately, okay? And I like thinking of it in terms of the heavier one, okay? So this heavier guy will have an acceleration, force equals mass times acceleration. You can use the force divided by the mass will equal the acceleration idea, but it won't be the total anymore. It'll just be the force, the sum of forces for the 5 guy divided by the mass of the 5 guy will equal the acceleration of the 5 guy, the 5 kilogram one. So the mass of the 5 is definitely 5. The forces is going to be something to talk about, but it's accelerating at 2.45 meters per second squared. I'm just going to say positive and understand it's going down to make a little bit easier sense here. So we are going to have 2.45 will equal, divided by 5, will equal, well, what is the sum of the forces on the F of 5, the 5 kilogram weight? You would have it being fully affected by gravity, 5 times 9.8, but it is being pulled upwards with the force of the tension. The tension is pulling up on this while gravity is pulling down on this. And that tension is going to counteract it, and therefore the sum of the forces would be 5 times 9.8 gravity. It won, so that vector should be a little bit longer, minus the tension, which is pulling upward on it, will equal this. And if we solve for this, you'll find out that the tension is equal to 5 times 2 point, I thought I had it solved, 2.45. You end up with 5 times that, 12.25 minus 5 times 9.8, and minus 9, 5, oh my gosh, 5 times 9.8. You would end up with the tension is equal to 36.75 newtons. Ask yourself, which direction is it going? Well, the tension is going up, the acceleration was going down. You can deal with all the positives and negatives that way. I think it's easier to think of the 5 times 9.8, the force of gravity being counteracted by the tension. In reality, you're supposed to go, the tension is being counteracted by the force of gravity and making it a negative because the negative was actually winning with it going down. I don't like it as much, okay? That's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.